Hi there, this is Dr. Stephen Jones. I'm going to be talking to you today about a linear programming problem, an application, and I would like you, if you would, to turn to Chapter 8 of your textbook. Now in my version, it's pages 308 to 309. We're going to be doing an ingredient blending application, the diet problem. That's section 8.6 in your text. And if you haven't gotten there, pause this video for just a moment and then go ahead and start it up when you get to that diet problem. Okay, I'm assuming that you are in the same place that I am in the textbook. And I have an Excel spreadsheet opened up for you to be able to see how I've laid the problem out, and it's very, very much like what you see in the textbook. So I'm going to show you how to set up this problem within Excel Solver. If you have not downloaded the add-ins for Excel Solver, let me show you quickly, if I can. Go down to Options, and then to Add-ins. It just takes a moment when you're using this program here. There we go. And you want to do Manage Excel Add-ins. Click Go. You want to make sure that your Analysis Toolpak, the Toolpak VBA, and the Solver add-in are all in your Excel process. I'm not worried about Euro currency tools. Then you would click OK. I'm going to click Cancel because I've already added them. But you would click OK and it would install those add-ins. And that's what we're going to use for linear programming today. So if you'll take a look, I've set the problem up just like you see it on page 309 of my version of the textbook. Yours may, if you have a different version of the textbook, it may be in a different page, but it'll still be the diet problem in the ingredient blending application. So you'll notice that I have set it up looking like this with the parameter data that you see earlier in my table 8.5, where it has, although it's in a different format, it has right here the information that you need on nutrition. It has here the cost per pound for your ingredients. Now, you'll remember that grain A is 33 cents a pound, grain B 47 cents a pound, grain C is 38 cents a pound. And then each of the grains has, on a per pound basis, a certain number of dietary units of protein, riboflavin, phosphorus, and magnesium, and that the total weight of each one in terms of a pound is 1 pound each. Later in the problem, you'll notice the constraints. One of those is cost. How many ever pounds of grain A that you use, it will be 33 cents per pound for grain A, or a part of it would be part of 33 cents. And the same thing for grains B and grain C. So if you use half a pound of grain A instead of 33 cents, it would be 33 cents divided by 2, or 16.5 cents. The summation of these is going to be your total cost. So the amount, that's the solution, that is the number of pounds or parts of a pound of grain A times 33 cents, amount of grain B times 47 cents, and amount of grain C times 38 cents totaled up will be your total cost. And that's also known as the sum product, and you'll see the equation when I write it. Right now, it shows that there is no amount. There's zero, although we don't have zeros in there right at the moment. You also have constraints that you need to have at least 3 units of proteins. That's the right-hand side. So the right-hand side of your formula is how much you need of each of these. You need at least 3 units of protein, 2 units of riboflavin, 1 unit of phosphorus, 0.425 units of magnesium, and the total weight is 0.125 of a pound, which translates into 2 ounces, because that's 1/8 and 2 ounces is 1/8 of a pound. So how many ever you have here of the left-hand side of protein, that's how much you're going to get here. You have to have at least 3 units of protein by combining this amount of grain A with 22 units of protein in grain A, this amount of grain B with 28 units of protein per pound in grain B, and this amount of grain C with 21 units per pound of grain C, and that'll be the same thing for each of these. Now, you need to have at least 3 units, 2 units, 1 unit, and 0.425 units. You may have more than that, but you need to have at least that. And then you need to equal 0.125 pounds right here. So those are the restrictions, along with the fact that you cannot have 0. So you have to have some of each of those. You cannot have 0 amounts. That's the non-negative factor. Well, pardon me, you can have 0, but you can't have negative units. So you can't take away grain from it. So you may have 0 or more units of each of those grains. If you can use just A and B and you don't need any C and you get the least cost, that's fine. So let's click on the total cost. You'll notice that I have outlined each of those areas where numbers are going to be calculated with boxes. You don't have to do that. I just do it for ease of us being able to see where the calculations are being made. So I'm here with this information. I go up to the Data tab, and you'll notice over here that I have Solver. So I click on Solver, and because I've clicked on this total cost cell, it automatically puts it in here as my objective. And I'm trying to keep the lowest cost possible, so I'm going to minimize that. Now I'm going to calculate all of this by changing the variable cells that we're wanting to see how many pounds of those we're actually calculating out. Okay. Now, before I go farther, I need to put one other formula into each of the cells here. I've got this set up to the point of being able to subject this to the constraints. But I need to enter the constraint formulas into my Excel spreadsheet first. So let me close this and go back here. So I need to do what's called a sum product. So I type that into my Excel spreadsheet, and I'm going to sum up the product of these cells right here with these cells right here, so that B5 will be paired with B6, C5 with C6, and D5 with D6. But I'm also going to use it down here for calculations, because the amount of each of those grains is not only calculated to get my cost, it's also going to be calculated to get each of my amounts in there. So to do that, I need to set this cell, and I do this by hitting the F4 key. Not the F key and the 4 key, but you'll notice the function 4 key at the top of your keyboard. And what I've done now is I have set so that B5, C5, and D5, the amounts cells, are always the ones that are going to be cross-multiplied with whatever numbers I'm using down here to try to calculate other amounts. I finish out the formula, and right now I have 0 in here because I have zeros up here. I take and copy this formula down to these formulas right here. Pardon me, these formulas right here. And so now in this cell, you'll notice that I'm calculating the amount of grain A with 22, the amount of grain B with 28, the amount of grain C with 21 units of protein, and I come up with an amount here. And this amount has to be greater than or equal to this amount right here. So let's go back, highlight total cost, bring solver back up. You'll notice I'm still up here with E6. I still have my variables here, B5, C5, and D5, that I'm going to change. Now I need some constraints. So I click into the subject to the constraints box and click add. And then I click on this button here to allow me to do my references. I need to highlight those constraints and it comes out with less than or equal to, which is actually what shows up in your book. That's wrong. And I'm going to show you why that's wrong in just a moment. But let's leave it, because your book says less than or equal to, and that is a typo. But we'll go ahead and enter it so that if you were to do that problem, you'd say, what in the world's going on? And we need it to be less than or equal to each of those. Remember, our signs here show greater than or equal to, so having the less than or equal to, which your book shows, is just incorrect. And we click OK on that. Then I'm going to add one more, and that is that this constraint is equal to that constraint, so that you need 2 ounces of cereal. Make sure then that you have make it the unconstrained variables non-negative, so it can be 0 or greater, but it cannot be negative. And then change this to a simplex LP problem, and then solve it. And we're going to show you why that's wrong. Take a look. Those numbers are not the same numbers as what you see in the book, and you'll notice that this is 2.99, 1.92, 0.96, 0.425. Those are all less than or equal to these numbers, and that's not what we wanted. We needed at least 3, at least 2, and at least 1. So we're going to go back to solver, and we're going to say, oops, we made a mistake, and we're going to change it. We're changing it here to the greater than, which is what it should be. And now we're going to solve it again, and then we'll close, and you'll notice now that you have the numbers that were in the textbook. And it's calculated out then that you need 0.025 pounds of grain A, 0.05 grain B, 0.05 grain C, and when it calculates it out, you get 2 ounces worth of grain. Plus, you are greater than or equal to each of the constraints that you set here on the right hand side, and your total cost is just over 5 cents. And that's how you do a ingredient blending application problem in linear programming. Please let me know if you have any problems. Thanks.